Okay, so we've been looking at a unit circle, or a circle in general, and we've found a way to define sine, cosine, and tangent. What we want to look at is different ways of finding values for sine, cosine, and tangent. Well, for some angles, some special angles, it's fairly easy. So, like if I look here at the origin, uh, pencil here, there we are. Where the point is, well, it's going to be R0. So let's take a circle here where we have some radius of R in there. If I look at the sine of 0, that could be 0 degrees or 0 radians. I know that uh, the sine is going to be the y coordinate. In general, we had that the sine of theta was y divided by r, the y coordinate divided by the radius. So it's going to be 0 divided by r. Of course, 0 divided by r is just 0. So the sine of 0 is 0. And if we look at the uh, cosine of 0, cosine of 0 is the cosine of theta, if we recall, was the x coordinate divided by r. Well, the x coordinate is r, and the radius of the circle is r, and r divided by r is 1. So at 0 radians, or 0 degrees, you get that the sine of 0 is equal to 0, and the cosine of 0 is equal to 1. And the tangent, while we're at it, the tangent is the y coordinate. Whoops, let me fix this a little bit here. We'll clean that up there. I need to put in an angle. I always have to have an angle. It's not just sine, it's sine of an angle. So if I have the sine of theta, I know that that is the y coordinate divided by the x coordinate. So at 0, we have the tangent of theta is 0 divided by, let's see, r. As well, the x coordinate would be r, and so that is going to be 0. So at 0 radians, 0 degrees, I know that the sine is 0, the cosine is 0, and the tangent is 1. Another nice angle that we can look at is if we had a 45-degree angle. At a 45-degree angle, we know that the x coordinate and the y coordinate are going to be the same, so that the x coordinate and the y coordinate will have the same value. So if we call this distance x, I know that x is equal to y, y equals x in there. And so by the Pythagorean theorem, I know that when the radius, when the angle is 45 degrees, or pi over 4, I know that x squared plus y squared equals r squared, and x is equal to y, so x squared plus x squared equals r squared. And so I get that 2x squared equals r squared. So x squared is equal to r squared over x squared, or r squared over 2. Let's do math here, David. R squared divided by 2 would give you the x coordinate. Get back to my pencil there. X squared over 2. So if you take the square root of both sides, that x is either plus or minus the r over the square root of 2. If you take the square root of both sides of this equation, I get that x is either positive or negative. And that's going to depend on where you are on the unit circle, whether you want the positive or the negative one. At 45 degrees, I definitely want the positive one. In there, my x coordinate is definitely going to be positive, and the y coordinate will also be positive. They're going to be the same number. They're going to be r over the square root of 2. And we can kind of clean that up a little bit. Let's multiply by square root 2 over square root 2. Let's multiply by 1 in the form of square root 2 over square root of 2. And we'll get r times the square root of 2, all divided by 2. And so the sine of pi over 4 is the x-coordinate or the y-coordinate divided by the radius. The y-coordinate is the same as the x-coordinate, r root 2 over 2, and then I'm dividing that by another r. And what happens there is the r's will cancel out, and so it doesn't depend upon the radius at all, which is what we expect, that ratio should be fixed. It should be a fixed radius, that's fixed ratio, and that fixed ratio is root 2 over 2. The sine of pi over 4 is root 2 over 2. Similarly, the cosine of pi over 4, it's going to be the um, x-coordinate, which is root 2 over 2 times r, divided by r again, divided by the radius. And the r's cancel out, and so we get square root 2 over 2. So we get the same ratio there for cosine and sine at 45 degrees or at an angle of pi over 4 radians. The tangent at pi over 4 is y over x. So root 2 over 2 times r divided by root 2 over 2 times r. The x and y coordinates are the same, and so the tangent of pi over 4 works out to be 1. Okay. Another nice point to look at is the point 0, 0, or the point up here, right up here at 90 degrees at pi over 4. In that case, I know that the x-coordinate is 0 and the y-coordinate is r. So that the sine of 0, or not sine of 0, sine of 90 degrees. I already did the sine of 0. Sine of 90 degrees, or the sine of pi over 2. 90 degrees is equivalent to pi over 2. The sine of pi over 2 is going to be the ratio of the y-coordinate to the radius. So the y-coordinate is r divided by r. So I end up with 1 there for the sine of pi over 2. Cosine of pi over 2 would be 0 divided by r. The x-coordinate is 0 at an angle of 90 degrees in the standard position, or an angle of pi over 2 in the standard position, and 0 divided by r is just 0. And finally, the tangent of pi over 2, well, that's going to be 1 divided by 0. It's going to be the, r divided by 0. It's going to be the y-coordinate divided by the x-coordinate, but you can't divide by 0. That is undefined. We do not have a value for the tangent of 90 degrees or the tangent of pi over 2 radians, because at that particular point, the function is undefined out there. So we have to be careful about that. So there's a few values that we can get, but if I know those, I can actually find out what the other values are going to be fairly easily. If I look at an angle of, let's scroll up here a little bit. If I look at an angle of how about 3 pi over 4? If I look at an angle of 3 pi over 4 here, 45 degrees, if I go from the x-axis all the way around to here, it's 135 degrees. It's the actual angle, 135 degrees, or 3 pi over 4. The coordinates of this point are almost the same as the coordinates of that point. I know that the coordinates of this point were square root 2 over 2 times r and square root 2 over 2 times r. The coordinates of this point, the height is going to be exactly the same, and the y value are going to be exactly the same. I know that at a 45-degree angle, I know that the x-coordinate and the y-coordinate are going to be almost the same, except for the x-coordinate is going to be negative 2 over 2 times r, and the y-coordinate is going to be positive 2 over 2 times r. Our y-coordinate at this point is still positive, but the x-coordinate is negative. And so if I'm looking at that angle there, if I look at say about the sine of 3 pi over 4, which is the same as 135 degrees. The sine of 3 pi over 4 is going to be that y coordinate, square root 2 over 2r, divided by r again. The r's cancel out, and I end up with square root 2 over 2. The cosine of 3 pi over 4 is going to be negative square root 2 over 2r divided again by r. The r's cancel out, and we end up with a negative square root 2 over 2 in there. So it's the same values for sine and cosine, just the sign is different. So the sine of pi over 4 and the sine of 3 pi over 4 are both root 2 over 2. The cosine of pi over 4 is positive root 2 over 2, and the cosine of 3 pi over 4 is negative square root 2 over 2. The number stays the same, we just the sign is different. Okay, another angle that's useful that are in there, we can also get some more of our special angles in there. That's why they're special angles. If I continue to work here in the first quadrant, if I take a 30-degree angle, well, it turns out in geometry, it might have been a while that you learned this, that if you have a right triangle where one angle is 30 degrees, it turns out that the vertical distance here, the side opposite that 30 degrees, is 1/2 the hypotenuse. So the hypotenuse here, in this case, is r. So this is a special angle where we can work with here. That if your hypotenuse is r here, and I'm looking at a 30-degree angle, the side opposite that 30 degrees is 1/2. Of course, I'm placing that right triangle inside the unit circle there. But if I look at the sine of 30 degrees, which is the same as the sine of pi over 6, what that would be 1/2 of r divided by r again. And so it works out to be just 1/2. The r's cancel out. And so the sine of 30 degrees is 1/2 in there. If I look at an angle of 60 degrees in that unit circle, 60-degree angle in there, or pi over 3, if I look at the sine of 60 degrees, that's the same as the sine of pi over 3 in radians, if we measure that angle in radians. What happens is the little angle up here is 30 degrees. So the distance down here is 1/2 r. And I guess what I need to do is find what is that third side of what's the y coordinate there? And actually it's going to be the same, well, the y coordinate is there, but I know that it's going to follow the Pythagorean theorem that, ooh, what happened there? I don't know. That according to the Pythagorean theorem, that 1/2 r squared plus y squared has to equal r squared. So what I end up with is r squared over 4 plus y squared equals r squared. And if I subtract r squared over 4, if I subtract r squared over 4 from both sides of the equation, I'll get y squared is equal to, now this is 1r, and I'm subtracting 1/4 of r, so I'm going to end up with 3/4 r squared is equal to y. And so if you take the square root to get y by itself, you're going to get two answers. You're going to get a positive and a negative. I'm going to get the square root of 3 over 2 times r for the y coordinate. I want the positive one here in this case. So the sine of 60 degrees is going to be 3 pi, sine of 60 degrees is this, where's my pen again? There we are. Get my pen back going here. Sine of 60 degrees is going to be the y coordinate here, root 3 over 2 times r, divided by the r, and the r's cancel off, so I end up with root 3 over 2 for the sine of 30 degrees. If I want to go back and look at the cosine of 30 degrees, which is the cosine of pi over 6, that x coordinate, well, that's the same as pictures I've done down here, the same measurements here. What I'll find is the x coordinate here is root 3 over 2 times r. So the cosine would be root 3 over 2 times r divided by r. Again, the r's cancel off, and I end up with root 3 over 2. Okay, so there's a bunch of special angles that we can find the values for them. And we can kind of summarize them in a table. We haven't found all of them yet, but we can summarize them in a nice table here. So the angle uh, in I'm going to list the angle twice. The angle in degrees and the angle in radians. And I want to talk about the sine of theta, the cosine of theta, and the tangent of theta. And let's do 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So in radians, that's the same as 0. Pi over 6 is the same as 30 degrees. Pi over 4 is the reference, is the angle for 45. Pi over 3 is the radian equivalent of 60 degrees, and pi over 2 is the radian equivalent of 90 degrees. I hope that we're working on memorizing those. We're going to see those quite a bit. And as I refer to an angle of pi over 6, I want you to also think of that as 30 degrees, or an angle of 30 degrees. I want you to also think of that as pi over 6. So what we had was the sine of 0 was 0. The sine of pi over 6 was 1/2. If we scroll back up, you'll see that. The square root 2 over 2 was the sine of 45. Square root 3 over 2 is the sine of 60. And 1 was the sine of 90 in there as well. Now the cosine actually worked in the reverse order. If I go back and scroll up here a little bit or rewind the video a little bit, you'll see that the cosine of 0 was 1. The cosine of 30 degrees is root 3 over 2. The cosine of 45 degrees is the same as the sine of 45 degrees. The x and the y coordinates were the same. The ratios were the same. It's root 2 over 2. When you get to 60 degrees, the cosine turned into be 1/2. And at 90 degrees, the cosine was 0. We didn't do all the tangents, but tangent of 0 was 0. The tangent of pi over 6 turns out that that's root 3 divided by 3. If we go back and do the math for that, we'll find it's root 3 over 3. 45 degrees, the tangent is 1. And 60 degrees, the tangent is just the square root of 3. And at 90 degrees, it's undefined. All right, so there's a handful of angles that we can work with and find the values of sine and cosine. Those are some special values. It would be really nice if you memorize those. These are ones that math teachers, engineering teachers, physics teachers like to use a lot because they have very nice values. And I know it's a lot to memorize. I'm telling you to memorize a lot this first couple of days. But having these down will be very helpful in your career going forward. Yes, you can always get it off your calculator, but there are some things that, it's just nice to know, that if you have something, it's right there, it's immediate, you have it right with you. You don't have to spend that extra time going up and finding it. You don't have to, you've got a calculator that can add, 15 and 5, but 15 and 5 or 15 and 5, is 20. You don't need to go uh, go punch that into the calculator. It's just if you've got it there, it's immediate. You've got it. It's handy. Saves you time. Saves you energy. Saves you money. There, it takes a little more brain power to get it in there to start with, but we do want you to get that in there. Okay, so these are values for sine, cosine, and tangent. There are a few patterns that you look at there. I hope you can see them uh, in there if you think about it. One of the things that I like to see, um, we don't really talk about it this way, and it only works between 0 and 90 degrees. But one of the patterns that I see is this is you can think of this as the square root of 1/2. And this is the square root of 0/2. Of course, you got the square root of 2/2 and the square root of 3/2. And this is actually the square root of 4/2. Um, it's a nice way to look at a pattern for those. You don't necessarily want to look at that as any sort of thing other than a way to know that pattern. But square root of 0 is 0, so 0/2. So it's 0, 1, 2, 3, 4 is the pattern for the numerators. And then when they've got nice square roots, you just take the nice square root. So the square root of 1 is 1, square root of 0 is 0, square root of 4 is 2, but 2/2 is equal to 1. So that's another way, a little sort of reference that you can use there to kind of cheat to know these. Sine goes from 0 to 1, cosine goes from 1 to 0. So the reverse order, same values, just the reverse order in there. So there's a lot of similarity in here that helps us out with those, finding those values. Okay, so there's a handful of special values. We can also get values out of our calculator as well, if instead of um, using uh, your brain power, if you've got an angle that's not one of these special ones, and you need to know the values of sine and cosine, let me see, where did our don't I have that open? I don't have that open here. Let me pull up yeah, that's a good spot for it here. Let me pull up Desmos. Desmos, let's do the scientific calculator in there. If you want, what are you doing? Take me to Desmos. So Desmos Scientific Calculator has our trig functions on there. There they are, sine, cosine, and tangent, down here in the bottom corner. And if you need the sine of 30 degrees, um, it is here in degree mode. When we're looking at that, we are in degree mode. Be sure to check the mode that you're in. It tells us that the sine of 30 degrees is a half, is 0.5. But if you need the sine of, oops, let me get out of annotate mode here. Get back to the mouse there. If I need the sine of 23.8 degrees, I can just do sine 23.8, and it gives me the value of sine of 23.8. Cosine of 137 degrees would be this negative 7.31 in there. And so we can get the values out of the calculator. It's typically built in as a function there. And you do have the option to be whether you're in degree mode or radian mode. Make sure that you're in the proper mode. If I need the sine of, let's see, what's one that we know? How about pi divided by 3? Sine of pi divided by 3 is this 0.8660. And if you actually check the square root of 3 divided by, whoops, I want to get out of there. So let me, clear will work. Square root of 3, and then move over to get outside of that, divided by 2. root 3 over 2 is that same value as the sine of pi over 3 in there. So we can get the values from our calculator. Be sure to check that you're in the proper mode, whether you're in radian mode or degree mode. Um, I guarantee you're almost always going to get a question wrong. Every student does it at least once because their calculator is in the wrong mode, whether in your degree mode or radian mode. That's really important. Be sure to check that every time you uh, go to do it in a problem. Check the mode to see whether you're in degree mode or radian mode. Very important there. All right, so we can get the degree for any angle off our calculator, and there's a handful of ones that I expect you to memorize in here as well. So we can find the sine and cosine and tangent of any degree, any angle using our calculator. And there's some special ones here that we have memorized, ones that are very useful to have as well. All right.